Thank you for joining. This is another edition of the Cady Talks. We're going to have a good conversation today. We're going to be talking a little bit about our Saber portfolio, but most importantly, we have a guest customer on today. So we're going to jump right in. And as we're going along, if you have any questions or comments, you can use the feature on Zoom and submit your Q&A questions, and then we'll address those as we go and at the end as well. So to get rolling here, on our panel today, myself, Michael Cady, I'm the field CTO with DZS, and today we've got Jason Lauzon, who's a member of the team. He's a director of our optical solution team. He's our SME on Saber, so he's the right guy for this call. And then we've been lucky enough to have a customer guest star today. We got Alain Brunet, who is the manager of fiber operations at Vianet up in Canada. So we'll talk a little bit more about his application and how the Saber product fits into his needs. But really, again, for those of you that haven't been on these sessions before, the goal here is to have more of an informal conversation. This isn't really, we're not going to try to bore you with 100 slides. We're not going to, go into a full webinar presentation. We have a few slides that we'll talk to, but it's more of a conversation. And those that know Jason, know that he's got a real passion for this product. So we'll try to keep him under control and not let him go for too long, so you guys can have your morning back. But all of that being said, Jason, we're having this conversation. We've got Alain to join us, but really high level, why is Saber so exciting, and why would our customers be interested in it?
Perfect. Thanks, Mike. And pleasure to be here with everybody today to talk about Saber. So we'll start things off by just reintroducing most of you to what Saber is and why you should consider Saber. So on the left-hand side of your screen here, you'll see that traditional DWDM transport networks, specifically regional DWDM, data center interconnect, the metro long-haul DWDM. This is where most of your optical transport with the typical vendors play, right? There's 100 gig to 800 gigs, ROADM technology, massive transport capabilities in the DWDM coherent space. In that area, what we're trying to do with the Saber platform is to evolve the traditional space of the traditional DWDM transport section of the network. So we're calling it the evolving access edge transport, and that's showcased here on the right-hand side of the slides. And this is where you start getting into the edge application. That's where your last mile is, or your last mile broadband capabilities. And now, as we're moving into the future with XGS PON, 25 gig PON, 50 gig PON, and thereof, we're seeing more and more bandwidth needing to be utilized at the access edge. So what we're calling it with the evolving access edge transport is built to move traditional DWDM transport equipment to work and bring that right to the edge of the network to facilitate the massive bandwidth transport capabilities in a coherent aspect. That's DWDM, that's 100 gig, 200 gig, 400 gig, 800 gig plus. So that's pretty much what it comes down to in a compact, hardened, -40 to +65 capable system that can be deployed anywhere in your network.
And that's one thing I wanted to highlight, Jason, was the small form factor, very compact 1RU, low power. You've got your multiple sleds or slots inside in the 1U, depending on what module you stick in. And then again, if you need more than one of those at a site, we can daisy chain them. But it really gives you that simple, low power, low space required. Obviously, we mentioned that it was hardened, and then you have that flexibility to add and go on. So good intro, good highlight. But really, what I'd love to do is jump in and let's meet Alain and talk a little bit about Vianet. And Alain, if you don't mind, just give us a little high level of what your company does and what your role is and everything like that. So
morning, everyone. So my role at Vianet is I'm the manager of fiber operations. I've been with the company for probably about 22, 23 years. Vianet is a privately owned company in Ontario, Canada. These days we're about 170 employees. We build our own fiber network. We're not really dependent on third-party services anymore. We've been in the business for about 37 years. so it's been a long time. Just a bit about our network in the Ontario region. We have a vast network, so we go all the way to Toronto, and all east, all the way out to Fort Francis and all these remote areas, Kapuskasing, Timmins. Sudbury is our hub. That's where the office is. So most of the services come out of Sudbury, which is why we need a lot of bandwidth to go up to Toronto, as Toronto has the exchange at 151 Front Street.
Okay. And you had mentioned you have a vast network in a lot of different areas, but you also have some locations that require the hardening capability. And I think if we kind of, we got one slide here that we want to kind of talk to that kind of shows what the need was, and what your goal was, and then how we fit in there. So I'll let you kind of summarize where we fit into your network, if you don't mind.
Sure. So for the last couple of years, we've been actually talking to a lot of vendors, at least the transport vendors, because we've had a legacy transport system that's been set up between Sudbury and Barrie for over 10 years now. It was one of 10 times. It was a 4 times 10 gig circuit, but obviously we need more capacity. Some of the problems that we've had when discussing with these vendors was always the distance that we've had between, especially Sudbury to Parry Sound. The 178 kilometer distance with the high loss was always a problem for most.
And even the 155, going over to ESSA, obviously is still a long distance.
They're pretty long links, and one of the problems is that we didn't really want to start using Ramon or even put in a site in the middle. If we repeated the signal in the middle, it would bring up our cost to co-locate equipment, and also obviously additional transport costs. So when we heard that Zone came out with the Saber platform, and we've been using Zone since the Paradigm days for like 25 years, we're well aware of all their products. So we started talking to them, and they told us they believe they could do it in one shot. And we got the equipment, tested the equipment in the lab with Jason. We had no real issues in the lab. We deployed it, ended up there was more loss on the fiber than we anticipated, and Jason was still able to get the link up and running, and we've had it up running for about a couple months now. I think the link between Sudbury and Parry Sound, we haven't had any issues with it. And the link between ESSA and Parry Sound we've had up for maybe about a month, and still no issues with it. The good thing about one of the other, they mentioned the hardening part that was important to us, because we have outdoor cabinets, and we plan on using these outdoor cabinets with our transport side of the network. So a lot of the vendors that we talked to, they supported some of their equipment, their transport equipment. It was hardened, but not everything. And then a lot of their equipment was not really hardened, was more like -10 Celsius, which if we had a failure or power failure in one of these outdoor cabinets, that would be a problem for us. Because our winters are pretty cold out here in the north, and -10 just doesn't cut it.
We were talking about how cold it was this morning, even so, and it's not even a bad storm right now. So, yeah, absolutely. So I appreciate that, and it was really a good overview. And I think you hit on some of the advantages of the product line, and I laugh a little bit when you called us Zone, because that tells us that you do go back in time a bit. Obviously we're DZS, but it's exciting to see that you've had experience with the company, all the way back to Paradigm, and then Zone, and now DZS, and you've got projects going on. So it's exciting. Jason, did you have anything you wanted to add to what Alain was saying, or even any questions you had for him?
No, just to add on to what Elaine's saying, the solution that he's talking about is a combined hardened plus non-hardened capability, but we're able to do it with a single kind of solution that's the same on both ends, and that's bringing it all together and how we're creating that evolving edge transport capability with a single kind of response that can fit in your central offices, your huts, your data centers, and all the way in your outside plant cabinets to facilitate an easy way of turning up high bandwidth services like 100, 200, 400 gig, and soon to be 800 gig as well. And then, when you combine that with also ROADM capabilities, it's
Sure.
significantly powerful for you to, deploy next generation networks.
Well, and then obviously now you've got that path, and if you have additional circuits in the future, you'll be able to grow it and everything as well. And kind of lends into, we talked high level about Saber, we talked a little bit about this use case, but there are other use cases, that where Saber fits. And I, the way I look at it is it's not going to solve every need, but the needs that it will solve, it solves them very well. So you have to kind of have that creative thinking where, where would this box help me, and what different areas of your network could it play into? But if we start digging into some of the other scenarios, Jason, maybe you can talk to these a little bit, but at the same time, Elaine, if you have any thoughts or comments about, how things are deployed. But I think even, in the upper left, I mean, that's a pretty good example, of your part of your network, between Sudbury and again, so, having part of it in the outside plant cabinet, and then part of it in a central office, and then you have that additional span beyond that. So, but go ahead, Jason. I'm sorry, I'm rambling on.
No, absolutely. I could talk a little about the use cases here, and you'll notice a slight variation from what you saw on the actual slides that Alain talked to about. We're transporting over 178 kilometers, and these slides I'm showing kind of 0 to 120, and there's a reason for that. So 0 to 120 kilometers is great with no amplifiers, right? But that doesn't mean that's all we can do. With amplifiers, we've pushed the limit to 178 kilometers point to point with nothing in between. And amplifiers are key to ROADM networks and then long haul capability, but there's multiple ways to kind of skin a cat, right? I'll use that convention to explain it. Long distance, long haul, metro, you name it, 100 gig to 400 gig, as shown in the top two sections there. And then the bottom, we can do that with full C-band DWDM ROADM networks to facilitate 25.6 terabytes of bandwidth capability in either direction, spanning thousands of kilometers, right? So and we can pull that all the way back to data center interconnects, you name it, across the board with our solution.
We have the 2-degree hardened ROADM blade, that sled, if you will, that fits into the 1U. And then
That's
if
right.
you do additional, degrees, you can stack that like we mentioned earlier, but it gives you a lot of flexibility. In this case, we have one example of a network, and then obviously data center interconnect, you got your multiple transport opportunities. You start going into some of the different topologies, so maybe talk a little bit to this, Jason. You mentioned the mid-span amps and the long distance. But what about even, a little bit more on the ROADM piece, perhaps?
For the ROADM piece, what you can start, thinking of traditionally with other vendors, they're creating these ROADM, networks between their central offices, but you start getting to a real massive mesh network when you can start incorporating your outside plant cabinet deployments within that DWDM ROADM network. So as Mike just mentioned, our ROADM solution is as a single 1 RU for 2-degree east and west capability. And then for every 1 RU, we can add 2-degree capability to a nice fit of 8 degrees in a 4 RU system that's 300 millimeters in depth that can be deployed from an outside plant cabinet, hut, and central office.
Yeah.
It's a very powerful solution to deploy anywhere in your network to create ring, mesh, hub and spoke, linear add drops, and then also my favorite, alien wavelength transport, along with spectrum sharing. So a lot of our customers, we're just kind of scratching the surface, have a lot of outside plant cabinets in their network. Other vendors that don't have such a hardened solution are not trying to push that because they want you to traditionally put everything in your central office, build more huts, spend those dollars to facilitate their data center level equipment. Where our solution is, let's use what you have in the field. Let's get a more cost-effective approach to expand to rural neighborhoods, as an example. It's a lot easier and more cost-effective to put in an outside plant cabinet than a 10 by 12 hub with full air conditioning, with dual redundant power supplies, et cetera. That's a lot of power and a lot of OpEx. Think of how much you can save when you just put in an outside plant cabinet that doesn't have to have, two redundant air conditioning system or heat pump system generating all that power on a continuing basis. And that's just during the summer months. Now that you start talking about the winter months, and you got to heat that place as well. So there's a lot of OpEx savings when you have a solution that's ruggedized to fit in all your aspects of your network.
So Alain, with your current projects that you're working on and stuff, are you continuing your plan? I mean, are you essentially going to have a lot of the linear add drop type scenarios, or are you looking at any future projects with ROADM or additional needs?
Well, there's about 3 more projects on the way. We've already purchased 4 more shells for 2 of the projects. These are all in outdoor cabinets, actually. So
Okay, so yeah, you're taking advantage of the hardening. Yeah.
yeah, and also space, right? Like these cabinets are not, they're not the largest cabinets. So space is always a concern, and power, of course, is always a concern. Because these are all on battery. If there's a power outage, we run them on battery. Of course, there's an option to put a generator on. But there's always a concern on what equipment we put in these outdoors cabinets, and
Sure.
the Saber platform doesn't really use that much power.
Yeah, absolutely. And there was another, point, Jason, this is kind of going back to the more additional use cases and some of the other scenarios, but I kind of like this slide because it lets you kind of see, like over on the right, this is one of the modules. You can see it sitting next to a standard iPhone, and everybody knows how big an iPhone is. So you can kind of get a feel for like the 4403, the size of it, and essentially, Jason, maybe talk to all the different capabilities of that one particular module.
Yeah, definitely. So I want everyone to kind of use your mind's eye for a second. And typical deployment specifically to the edge, you're probably, if it's GPON rolling into XGS PON, you're probably looking at like 10 gig NNIs, right? You got like some type of lagging system, east-west capability probably, but it's 10 gig NNIs today, and you haven't really upgraded to a 100 gig yet. Our solution allows for a seamless integration, so we can do 10 gig flexi capabilities for 4 times 10 gig per client port on our transponder card, and we got 4 of them. And then you can reserve those other ports for 100 gig NNIs. And then therefore in the future, you can also skip to 400 gig NNIs, right? So we have a seamless upgrade path to provide the capabilities of what you need today, and then give you an approach to upgrade without breaking the bank in the future. Because if your card can do your 10 gig aggregation today, your easy upgrade to 100 gig, and then have a path to 400 gig, you got equipment in there that's good for like almost 10 to 15 years if you really think about it, and how technology kind of transports or kind of evolves, which is you want to keep equipment in your network for longer, because your I guess your capex goes a lot longer.
Sure, absolutely. And having the flexibility to, have future proofing for your next circuits that come while still.
So I think maybe we lost. Alain, you still there?
Yeah.
Yep, we got a little pause.
Mike's back.
Yep. You want to be able to manage your network and have the ability to support the needs and such. And some customers, they're not even utilizing Extreme, for their management of the system. And it all depends on your network needs. But this is an evolving product for us that's rapidly growing and gives us the ability to, manage the network in a different approach. So go ahead, Jake, highlight a couple thoughts on this, and then we'll kind of jump into some of the questions.
Yeah, thanks, Mike. So the Extreme Transport is our NMS, so network management software for addressing NOC capabilities and GUI management, alarms, events, all that fun stuff that you're typically used to across both the transport and the access space as a single pane of glass. Looking at it from a transport perspective, it's what you would use in typical NOC environments to manage your network, configure your network, monitor your network, audit your network, and so on across the board. That's all based around NetConf Yang, but also has legacy SNMP support. So we're not forgetting about our previous platforms. We want an easy way of upgrading into a single NMS system that supports your existing equipment and then provides you a path for the future, so you're not left hanging any security vulnerabilities or any of that nature, with a clean way of monitoring and managing your network for the foreseeable future, all based on the latest and greatest software technologies in the industry.
Yeah, absolutely. And it's exciting. I mean, there's a lot to it. I mean, there's obviously different needs by different customers. Some customers, they like doing things via CLI, and some customers need a more robust advanced system. So it really gives a lot of flexibility in this platform. And that the picture here, you can just kind of see, I mean, there's our that's actually the ROADM card, depicted in the shelf itself. So again, a lot more information available. We can definitely dig into anything that is of interest. But what I'd like to do, obviously, whenever we do these sessions, one of the goals I have is to, get information out, kind of get you thinking a little bit. And then we always like to dig deeper in if people have additional needs or questions or of interest, we can always follow up. So
I'm gonna take a quick second here and just talk about a little bit about the ROADM card. So that ROADM card you're seeing on the screen here, we're showcasing just kind of like one wave on the spectrum, right? You can see the entire C-band spectrum, whether it's 100 gig, 200, 400 gig, et cetera. You can do that for our waves or alien waves as well, and that's specific. And it's really important because you can do spectrum sharing. You can use other people's transport equipment through our ROADM equipment, so we're very open in that regards. A little bit of the capabilities of our ROADM. So inside that one line card ROADM 4400, for each degree, you got pre and post ANT capabilities, you got OTDR capabilities, you got optical supervisory channel capabilities for management, and you got a coherent probe that can do PRBS BERT level tests from any one ROADM to any other ROADM in the network to provide SLA data like what's your bit error rate, what's your real-time optical signal noise ratio on a specific circuit, whether it's 100, 200, 400 gig. And this is very important data to retrieve on a moment's notice. So when you look at all that technology and you put it together into kind of like one call it a line card, this is quite a powerful solution that can be deployed anywhere in your network, up to 110 kilometers between sites without any additional amplifier. With amplifiers, obviously,
I thought you were going to say up the, but you did add without the amplifier, because obviously we have proof that we're doing much longer distance.
Correct.
So I wanted to catch you there, Jason, but you covered yourself.
120 and 110 is kind of like that sweet spot without adding additional equipment. Once we add amplifiers, we can go much further. As you can see, we're doing 178 kilometers.
Well, and obviously, the loss on the fiber, it varies per how old the fiber, all those factors, the quality of the splicing and everything. But, that's an impressive network that we've got, and I'm happy to hear, Alain, that it's running well for you, and look forward to the future.
Well, just to kick it, we're showing 178 kilometers at 37.2 dB loss, but I think, Alain, there's an extra 5 dB of loss on there. So
more like
in reality,
41 or so.
Yeah. So in reality, if you do the standard kilometers per dB ratio, under typical circumstances, if we didn't have that extra 5 dB, it's like 200 kilometers. If you really think about it, when you add that up into a typical loss matrix.
Yeah, pretty exciting. I'm going to go ahead and stop sharing, and then let's see, we have a few questions here we can kind of address. Alain, while I'm pulling these up, did you have any other thoughts or anything else? Jason, anything else you wanted to?
No, I think we're good. We can go right into the questions and fire away.
Well, one question, I think we already addressed this really, but it's more of a question for Alain, given that Vianet is sometimes deploying in cabinets with space and form factor decision. And I think we covered that. You mentioned that, especially with some of the new projects, you've got a cabinet that might not have a lot of room. So, that's definitely anything to add there, but I think we kind of covered that as well.
Yeah, for sure. Like the 1U form factor is definitely a decision maker for us in the outdoor cabinet solutions.
And
Yeah.
I'll expand a little bit on the 1RU form factor. So it doesn't just stop there at the 1RU, right? So it's got that pizza box approach, but you can stack additional shelves. So it's kind of pay as you grow. You don't want to get in there and put like a 14 RU system and you got all this real estate taken up and
And
it's
power.
being
Yeah.
wasted. Pay as you grow, or so just take up the minimum amount of rack space as you need. This is lower power, and if you need to upgrade, then you add another 1RU shelf. But if you don't need to upgrade, then that's fine. You got that real estate open. So save on power, save on real estate. Very important. But the ability to pay as you grow, you can go 1, 2, 4, up to like 20 RUs if you really want to, and have each one of those shelves tree up to a primary shelf with a single IP address. So we have that taken care of for you as well.
Yeah, and it's funny, Jason, you're answering some of the questions just by continuing on. There was a question in here about capacity scaling as broadband demands continue to grow. What strategies can organizations implement to ensure their optical transport networks are scalable without significant overhauls to existing infrastructure? And you can add to what you were saying, but you kind of, any thoughts additionally on that?
Yeah, so additionally add to adding the bandwidth demands, and I'm looking at the chat as well as we talk. Yeah, one of the other questions is how can you test and monitor fibers that are connected to the Saber system? So inside the Saber system, we actually didn't mention this, so that's a great question. We have actually a third kind of a port that's third-party optical spectrum analyzer. So you can actually use our ROADM to as a optical spectrum analyzer for any other DWM system that you have in that area. It can be used for our purposes, or it can be used for your third-party purposes, you name it. We give you the raw spectrum data. And that's how we can test and monitor the entire spectrum over our ROADM system, which makes it very easy to work with alien wavelengths, because we can see the granularity of the 6.25 gigahertz slicing of each specific wave going through the network. For capacity scaling, as bandwidth demands continue to grow, because each one of our ROADM ports support FlexGrid, we can configure any one of those add drop ports to be super channels, or however we want to slice up the spectrum, whether it's 96 channels, 48 channels, 64 channels, you name it, or just use them specifically as massive super channels for 800 gig or 1.6 terabytes per second circuits. Over any one of those add drop ports. So you have the ability to customize every aspect of your optical transport network, specifically the ROADM. So the C-band, obviously 1530 to 1564 range for all your optical transport capabilities. Then we reserve that 1610 nanometers L-band for the OTDR capability, which is very important for fiber cuts, link loss, span loss, that kind of nature. And we're utilizing that not just in the ROADMs, but also in the amplifiers, which we are doing with the lane.
Yeah, and you hit it on the head here. There was a question on how do you test and monitor the fibers that are connected on a Saber system, and you were talking about with the OTDR capabilities there. Now there's another question in here. I don't know. I think Alain, you can see the questions if you click on it. There was one in here. Somebody is complimenting your Canadian plaid. You probably know this person, so
we don't wear toots inside the building.
That's great. But no, listen, I've always promised to keep these, kind of as a short session. I never want to go more than 30 minutes. I think it's been great, and I appreciate Alain you jumping on, and Jason could talk about this for hours and is happy to do so. If anybody has additional questions or wants to deeper dive into any of the applications, again, we really didn't go into all of the speeds and feeds and all of that nature, which we'd be happy to do and look at any applications that we might be able to help you with. So, with that said, Alain, thank you very much for joining us, and look forward to, supporting you and working together, DZS and Vianet going forward. So again, I think we have one more question popped up real quick. For the network shown on the summary slide, what is the dB loss over newly placed fiber, or was it legacy fiber? 100 gig transport summary slide. Oh, okay. Going back, Jason, you see that question going back to?
Yeah, absolutely. So in his network, based on the added loss, Alain, I think it wasn't new fiber, right? I think it was legacy fiber because you already had existing systems.
This is old fiber that was on the rails. It's probably been there for about 30 years. That's obviously another problem about these dark fibers.
For legacy fiber, you typically design like 0.25 dB per kilometer. That's for any design for any other render across the board. For new fiber, you're probably looking at realistically 0.18 to 0.20 dB per kilometer for new fiber being put into the ground. This is very good. But for combining legacy and old, you typically use 0.25 dB per kilometer. So chromatic dispersion and PMD. So coherent optics have the ability of providing this data for you, right? So if you're looking for the chromatic dispersion over a given network, right, using coherent optics, the transceivers themselves actually have that in the performance monitoring capabilities. Now, I don't think this is localized to DZS. This is pretty much standard across any typical coherent optic in the industry today, from 100 to 200, 400 gig plus, with real-time optical signal noise ratio on the transceiver itself. That, like I said, can be used to correlate to everything else that's riding over that network, if that makes sense to you.
Okay. Well, again, thank you very much, and look forward to talking to you all in the future, and then we'll have additional sessions coming down the road.